Okay, so based on what we did in the last video and similar to what we did with arithmetic sequences, we can write a recursive formula for a geometric sequence. So if we want to find a term, a sub n, it's going to be equal to the previous term times r. And this is for n greater than or equal to 2. Okay? And that's what we were doing in the last video. So it says write a recursive formula for the following geometric sequence. So all we have to do is figure out what r is. Now, to figure out r, you take two consecutive terms, take the second one, and divide it by the first. And so what do you get here? Well, it kind of looks like they're going with decimals here, so I'm going to write it as a decimal. It's 1.5. And then just to check it, I can take these two and go 13.5 over 9 and see if that's also 1.5. Now I say just to check it because they told us it was a geometric sequence, so we believe them, but we'll just check. Yep, it's 1.5. And then if you want to, do another one, you can take these two and just to, if you really aren't sure it's geometric, you could do them all. I always call this getting out of doing the dishes. Oh, I have to work on my math. I can't do the dishes. Anyway, so 20.25 divided by 13.5, and you get 1.5. And there could be a typo or something, but it looks like these are working out that the ratio is 1.5. And so we're going to write the recursive formula a sub n equals a sub n minus 1. Well, times 1.5. I kind of want the 1.5 in front. And this is for n greater than or equal to 2. So I think I would prefer to write it 1.5 times a sub n minus 1 like that. It doesn't really matter, but okay. That's the recursive formula then, and we're done. Okay, one thing I forgot to mention, this is the recursive formula, but because it's recursive, you have to give the first term. You have to give them where it starts, which they tell us. We know what the first term is. I think I might have forgot that on the arithmetic sequence we did with a recursive formula as well. But yeah, you should give the first term. Okay.